Okay, another optional question, and there's a footnote over here, and the footnote says that you probably need to revisit partial fractions for this problem over here. It may not be obvious, but when we get to that step, I do want to encourage you to go back to problem 12 on page 136, and that link will take you right there, and I'll take you through the steps. It'll take you through the steps. All right, so this is a competitive problem, and it comes from the Berkeley Math Tournament. All right, and it's a tournament that tries to engage students that, I guess I think most students in the tournament are probably at the top of their game, and they're probably good at doing things like this. All right, now certainly if I were there, I would struggle with this, to be honest with you. Certainly, I'd rather sit calmly and try the problem without a competitive environment, but you realize you're in a competitive environment, that speed is of the essence. But not for us. What we're doing over here is just kind of looking through it. So what I want to do is walk you through it. But this took me time to get through, by the way. All right, it took me time to understand the question. It took me time to figure out what's going on. All right, so the first thing I did was I kind of start rewriting it. All right, so I took the main integral, and I wrote this one over here, which is an equivalent statement, by the way. All right, and why is that? Well, just looking at it for that, range of numbers between 0 and pi over 2, and yes, I do know this is improper, by the way, at both limits. What I'm looking at there is, the arctangent of the tangent between 0 and pi over 2 would, of course, just be x, right? X is between 0 and pi over 2. So that stands to reason. The next thing I do is I said, well, let's define a function then. All right, so the function I'm defining over here is f of y, and I write this over here. It looks very similar to what's above it, by the way. And I'm saying y is greater than 0. And I say, what would f of 1 look like? F of 1 would look like this over here. All stands to reason, by the way. Now, the question is, how do I figure out this here? That's my problem. But I have something like this over here, and I want to go to the next thing. All right? We're going to do this over here. We're going to put f of y down again. And what I'm going to do with that is I'm going to differentiate both sides with respect to y. So differentiate the left side with respect to y and the right side with respect to y. Now, differentiating the left side with respect to y is, I'm just going to call it f prime, with the understanding this is the derivative of f with respect to y. And differentiating the right side, a little more complicated, but really what am I doing? I'm just differentiating this part inside here, all right? And that doesn't look too bad to do, by the way. And I want to point out why that is. I'm really kind of looking at, and I'll point this out to you, I'm just looking at differentiating this, and I'm treating this as some constant, by the way. And that looks pretty easy to do, by the way. So it's going to be 1 over tan x times, and I'm taking this guy's derivative now. What's that going to be? 1 over 1 plus the argument squared, that would be y squared, times tangent squared of x, times the derivative of this argument and over here, and this with respect to y, and that would just be tangent of x. So that's done, and I'm kind of looking at that, and I would certainly like to simplify that, and if I were to simplify that, I notice that these things cancel off. And what he left off with, you left off with this business over here. Whoops, sorry about that. You left off with this business over here. All right? So I'm looking at that. I still think I'm not in a good spot, but I want to proceed forward. And the next thing I try, it looks not embarrassed, though. I agree with that. I did this. All right? And then I look at that. I notice the secant is just simply this over here. And then I made a u substitution. I said u is equal to the tangent of x. Let's write that down. If u is equal to the tangent of x, du would be equal to secant squared x dx. Yeah, I'm kind of seeing that. And then the question is, what else you're seeing? Let's take a look at it. You're going to make a substitution in here, right? And again, the substitution is going to be, we're letting u equals tangent of x, and d, whoops, sorry about that. I keep doing that, don't I? And d equals this over here. So, kind of just rewrite the integral again, all right? And again, this is f prime. And I got to make some substitutions over here. Let's just do the integrand first. So what do I see? I do see this, by the way, secant squared, this. I see the top. And what's that going to be? 1 du. What's on bottom? Let's take a look at it. You're going to get 1. Now remember, tangent is just u, so it's going to be y squared u. And this is going to be y plus, well, tangent squared, which is u squared. I see that. Let's talk about the limits, by the way. And as I do that, I want to write down, they're really kind of limits. We're looking at the limit as x approaches pi over 2 from the left side of my substitution, which is the tangent of x. And that'll give me the u. And what's that going to do? Well, if I did that, that would go off to plus infinity. That's why I'm getting this infinite limit over here. Let's do the other one, the limit, the lower limit. X goes to 0 from the right side of tangent of x, and that would just be 0. Stands to reason. So we're here now. I'm going to get my eraser out and start to erase things I don't need anymore. And I'm looking at this integration, and I just want to return back to the beginning of the problem. They said you need to go back and look at another problem to remind yourself about partial fractions. All right. Now, certainly, I realize someone said that's really tough. Even went back there and you looked at it. That might take you half an hour to look through that. All right. And you can imagine in a competitive environment how anxious you might be. But this guy here lends itself to partial fraction decomposition. All right. So I'm going to say if you need to do that, do the partial fractions, but you may have to look back over the notes, by the way. All right. You may have to go back over the notes. We actually did this problem before, or something similar to it, and it's right over here. It's problem 12 on page 136. And all the solutions over there and a video there for it as well. So let me go back over here, and I did the partial fractions, and I came up with the integrand would equal this over here. So what I do, I just rewrote it. So I just, took that integration, I threw it in there, and I just rewrote it. That's all I did. All right, what would I get over here? I'd get this business over here. All right? Then what do? I have to integrate that. All right? And, kind of looking at it, I realize I should put limits down, but it's just taking up too much room at this point. This guy's fairly easy to do. Well, let me write it down for you. It's going to be 1 over y squared minus 1 times the antiderivative of 1 over 1 plus u squared, which is going to be the arctan of u. I do see that. It's written right over here. The other guy's a little more complicated, and let's go through that. Let me get my eraser out, and I'm pretty clear that we're okay with the second integration, but I want to do that first integration there, all right? So what do I see over there? I definitely see y squared, it's coefficient. I see y squared minus 1, and the antiderivative of that thing is going to be, let's see, arctan of yu, and then you have to realize you differentiate that, you would get, a y there, so I have to divide through by a y. And what would I get there? I would just get y arc tangent of yu over y squared minus 1. And I'm seeing that right over here. All right? Then I got to evaluate the limits. I know that's difficult, and yes, I'm not writing down the limits for you, but I'll do it for you. And I'm going to say, the upper limit, well, let's take a look at that. And I have to be honest with you, it's the u is going to infinity now. And if the u is going to infinity, the arctangent would go to pi over 2. All right, let me write that down. So we get y pi over 2 over y squared minus 1 minus, again, if u is going towards infinity, this would be pi over 2 over y squared minus 1. Now, if I did the lower limit, it really isn't that bad by it, going towards 0. That just gives me a 0. So I get something that looks kind of strange, but I'm going to look at it and I'll write it down for you. It's going to be y squared minus 1. I'll factor out a pi over 2 on top. And you get y minus 1. And this reduces, at least conditionally, to y over 2 to y plus 1. And that's what's written right over here. All right? So let me get my eraser out. Again, we're just looking through the key and speaking through the key. And we're right over here. All right? Now someone says, are we out of the woods yet? Not really. What I know is I know f prime is equal to this over here. What I have to do, though, is I have to find f of y. And I do that by integration. This is a very simple integration, though. It's going to be pi over 2, natural log, absolute value, y plus 1 plus c. All right? So I know what f of y is. It's that. All right? Let me erase this over here and tell you where that's written down for you now. That's written right over here. Now, you may not remember what f of y is, but we wrote it down before, and f of y was this business over here. Same thing. What I don't know is I don't know the c. I got to figure it out. And the way to do that is to pick an easy value. Let me write this down for you. So pi over 2. I'm going to say an easy value to pick would be y is 0. And again, the y has to be greater than or equal to 0 in this case over here. So what do you get? You would get the natural log of 1 plus c equals, I'm trying to figure out the c, by the way, 0 to pi over 2. And again, I'm saying the y is 0. Well, if the y is 0, the argument here becomes 0. And what's the arctangent of 0? Is 0. So now I know that c, by the way, the natural log of 1 is 0. That integration is 0. So no c is 0. So I got it. And what do I mean by that? I know what f of y is. What's f of y? F of y is pi over 2 times the natural log, absolute value, y plus 1. What did you want to do, though? You want to do f of 1, by the way. What's f of 1? It's this integration over here. That's what our goal was. What's f of 1? Let's write it down. Pi over 2, natural log. 1 plus 1 is just 2, right? This can be written as pi natural log of 2 over 2. End of story. All right, I realize it's a tough problem, and certainly I know people often wonder how long it takes me to work through something like this. A long time, it does. Like this isn't typed up, and in a matter of minutes, by the way, it takes time to get through. I realize speaking through it, it might help you to get through it as well. But again, to be good at this is going to require a lot of work, by the way. My name is Ron Bannon. If you need to reach out to me, my email address is Bannon, B as in boy, the @ symbol, NNON.US. Thank you.